Today I am going to continue this compiler design subject, different complex topics of different units. Earlier I have taken the content of unit 5 and the topic was optimization, code optimization basics. Now I am going to discuss the fourth unit topic, that is symbol table management. You all are aware that at the basic of your compiler design subject you will get that the compiler design is the combination of basically set of phases, and why it is phases, because every particular output that is generated by different previous phase will be input for the next phase, and this particular phase modulation will be there, and through that the whole compilation process will be going on. So in that case, symbol table management is very important part of this compilation process, because whatever variable you are going to declare in this compiler design process during compilation of the particular source program into conversion of object code, in that a major role is just performed by the symbol table management. Why it is called symbol table management? Because whatever variable, either it is global, either it is local, or it is local, or you may say that the scope of this variable, from where to start in that program, where to end, what is the different scope of different variables, these all things will be managed by symbol table management. So it is very important topic. So now I am going to discuss is that. So if we are talking about symbol table, what is symbol table? So symbol table is a data structure. Why data structure? When you want to store a data into structured form, definitely you will require some data structure. So some specific data structures are involved in symbol table, and symbol table is a data structure created and maintained by compiler, because the particular data structure is itself created by compiler and maintained by compiler, because whenever the particular variable is introduced for different calculations, intermediate variables are introduced, the symbol table will manage this particular variable, store that their value is stored, a value is required in between, that will be supplied by the symbol table. So these all process, that's why it is called as created and maintained by compilers to store information about the occurrence of various entities such as variable names, function names, objects, classes, interfaces. So basically whatever data is in the particular program and that is used during the compilation process, these all data is maintained by symbol table by using symbol table through compiler. So this is the process. So you can see that variable names are there, function names are there, object names are there, classes are there, interfaces are there. These all are the symbol, all are the variables which is used in the compilation process. Symbol table is used by both the analysis and synthesis parts of the compiler. So anywhere you would require to generate any particular variable for processing of your input, for processing of your data, for processing of your computation. So for that purpose, it works during the whole phases of the compilation. It is used by lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation, machine dependent code optimization, then finally the object code level. So everywhere it is associated with all the phases. Now we are going to discuss the basic important aspects of symbol table. So there are, if you are seeing that the tokens are basically the content of symbol table, and first time you have to introduce that into the symbol table. First time it will be stored. If it is variable, definitely you have to create it multiple times whenever some new value is associated with that. So new variable is required, but at the level of constants, at the level of procedures, at the level of maybe keywords, at the level of operators, you have to just store one time information, because these are unique entities. So for variables, procedures, whatever is changeable, you have to create these different to different according to requirement. So when identifier are found, they will be entered into a symbol table, definitely, which will hold all relevant information about identifiers and other symbol variables, constant, procedures, statements. So whenever we are talking about variable and when we are going to store, so firstly you have to see in bottom, the symbol table is working as all particular level, means the analysis phase, that is lexical analyzer, syntax analyzer, semantic analyzer, in between intermediate code generation. So all 4 phases it would work, because this is a analysis pass, and work for code optimization and code generation also. Whenever you stored any information, it will have some basic information through which you can store it into the symbol table, and you will extract or traverse or access that information whenever you required. So for that purpose, there are some attributes which is associated with the particular variable when we are storing these particular variables into symbol table. Okay, so if you are talking about any name, like any variable is stored into the symbol table. So whenever talking about any name, any variable which is stored into the symbol table, it's having 2 things. First, its type, and second, its forms, its location. Means what is the type of that variable and where it is stored, because whenever you store any variable, it must have a type through which we can decide how much memory, particular memory blocks will be allocated to that variable, and where to store it, because different variables is already stored in that, and there is a memory number is there, and you have to fetch out that memory number where it is stored, and you have to provide that block according to its type. Like if any particular variable is of float type, so you know about float type, it will take around 2 byte space. So if you are providing 2 byte space to that float part, definitely that particular part is allocated for that. Okay, so that is the important part where you store any value. These 2 things are decided, that where to store it, that what location you should be used, and how much memory blocks it will just used for storing. Then it will be used by later the semantic analyzer and the code generator, because basic part is there. Why we are applying this compilation process? This applying for only the created the object code from the source code, so that we have provided a runtime environment for the input variable, and we can give that input and getting the output. For that we are just applying this compilation process. Now efficient to add new entries to the symbol table. So it is very, if you are talking about the characteristics of this, then you will find the third part. If any new entry is there, it is efficient to add new entries. There are different data structures are used. Whatever value is used, we are selecting the first particular data structure through which we can add this value in symbol table, because that is suitable for for storing that value. It is dynamic in nature, because dynamic allocation and static allocation both is there when memory is used by runtime environment. So definitely it is dynamic in nature, because different data structures, different data is of different type, and if you want to store the different data, definitely we have to use the different data structures for storing that, and we have to select the suitable data structure for storing. The basic problems in symbol table, because we are calling that it is a set of data structure in which we have to store the value. So if you are defining any data structure that is not suitable for every variable, we have already discussed in last statement, I have said that that is not suitable for every variable. So that is one issue. So format of entries is a very important issue, because if some different type of data is there and there is data structure is not suitable, we have to switch up that. So that is the problem. The second one is method of access, because different methods we are using. So one data structure is taking some kind of method, like if you are talking about link, basically binary search tree, so there is different method to access the data. But if we are talking about if that is called basically suppose linear list you are taking, so in linear list there is different strategies to use to access the particular variable. So these are the issues. And third one is place where they are stored. So finding out that place, because If you are using different data structure, their place will be changed. So identifies those places also issue in symbol table. So till now we have discussed what is symbol table, where it is used, what type of information we are going to store in the symbol table, what are the issues in symbol table. Now we are further going to content of symbol table. So basically, if you are talking about content of symbol table, so only two things are there. One is name and second one is information. So name is whatever attribute name is there, like variable A is defined, so capital A is the name of that variable if you're talking about A. But what are information? What is type of there? What memory block it is stored? What are the length from starting point to that, where the location it is? These all are comes into the information of the particular variable. Okay, so that is the complete combination of this name and information only contains of symbol table. What is the capabilities of symbol table? So first capability, checking determine whether the given information is in the table. So first capability means you can say that the particular method is checking. What do you mean by checking? If you are going to store capital A and suppose capital A is already defined in the symbol table structure, data structure, then what you have to do? Whatever new value you have to put up for capital A, the previous value is updated by capital A. That previous value of capital A is updated by new value. Second thing, if it is not introduced till this particular time, means that is new variable, you have to just create it, allocate it into memory and then store the value into that. So that checking process is very important. That checking process is just told us to the particular variable is already introduced or newly variable is there. If it is already introduced, some different kind of operation is there. If it is new variable, firstly symbol table will create the variable, then store the value. So first information is, first particular working is capability of symbol table is checking. Second, adding new information. Definitely when you are checking and finding out that that new variable is not introduced, what you have to do? You have to add that information into the symbol table, and through that the symbol table expansion is there, and every time whatever variable you are finding out, either it is new, means initially declared, or you have to declare according to your requirement some new variable is introduced. So for those purpose you can adding new information. So initially the first variable is introduced anytime, after that it will be just old variable and we have to update the value of that variable, but initially it add the different new information. Then access the information of name. So whatever name is there, their information is accessible, and where it is used for next particular variable, that is also connected with that. So when we are going to discuss the data structure of symbol table, at that time we will see that name and information of a particular variable is there. After that, in the particular data structure you will find that that variable is associated with some another variable in storing part, and you have to use the data of this variable to just pointing out some another variable if it is linked with that. So that will be there. So access the information of name. And the last one operation is deletion. If we find that some variable is not useful during the whole program and their use is also covered, so what we have to do, we have to delete that, because if you are taking that, definitely memory part is taken by the variable, and their variable is that variable is creating an overhead for the whole particular compilation process. So if we are talking about capability of symbol table, so this is checking, adding new information, access the information of name, and deletion. These are four basic operations that would be associated with the symbol table. Now symbol table entries. So if you are talking about symbol table entry, we will store the following information about name and each entry in the symbol table. Whatever data structure we are using, in that these are the different information which is going to store into the symbol table. So the name, we are using this string data type, size and dimension, then data type, its scope, its offset from the base pointer. Okay, these are 5 particular attributes which require, or we can say that this is the information related with this variable, because name is there, their size and dimension is there, the data type is there, their scope is there, either it is global variable or it is local variable or it is parameter variable, because it is a part of the procedure, then maybe it is the parameter, and then it's offset from the base pointer for local variables and parameters only, where different variables are defined in a particular procedure. Different variables are defined, definitely which variable is stored on that, where, and what is the interlinking between these particular variables, that all will be defined over that. So we will store the following information about name, and each entry in the symbol table is associated with attributes that support the compiler in different phases. So the symbol table will provide to storing all these information into the compiler. Okay, so the data structure is itself capable of storing all these information into that. So that kind of data structure will be used for the compiler design. How implementation is there? So linear array of records, 1 records per name. So the basic phenomena is we have to use linear array of record because it is compile time execution. You cannot say execution, it is compile time assessment of the particular program. So if you are talking about compiler time, the things are mostly static. The things are dynamic when we are using runtime environment. Okay, so linear array of records, 1 record per name. So that is the best approach to store the record. We are using linear array of record. Entries of symbol table are not uniform, so to make it uniform, some information is kept outside the table and pointer to this information is stored into symbol table. Because we are using different data structure where uniformity means that is not a linear data structure, you cannot say that the information is stored in very structured way. So what we have to do, we have to store that data, their information is associated, information is linked to next variable where the particular value is going to prompt or provoke that particular variable for accessing. So we cannot uniformly make, but one pointer is there for available pointer, as available pointer where we can insert new values, and there is a interconnected link which connect the different data. So first data is stored, second data is might be on some other place, maybe it is linear structure, that is one by one is stored, maybe it is some ununiform structure, but that information will be linked through some different structures. So that is very sorry, that is very important for that. Then record consists known number of consecutive words of memory, so names is stored in the record. So known number of consecutive words of memory means whatever memory name that is accepted by the memory, we have to name of the record like that. If you are talking about a student, roll number is the data, so we have to name the name of particular data is roll number, so it can be identified and is stored in the symbol table, although we don't very much meaningful for that, but still if you are putting the name of related to particular entity, then definitely it will be easily accessible for us, and whenever we refer that data from the whole data set, definitely we are easily addressable that data. Then it is appropriate if upper bound on the length of identifier is given. So it is very appropriate when upper bound on the length of identifier will be given, means we have to know how much blocks it will take to store the particular data into the symbol table. So that is very important. Like if you are talking about array, definitely offset is there, then number of indexes are also there. If you are talking about one dimensional array, definitely the number of indexes and offset both will be tackling the total storage of that array. If an identifier is given, definitely whatever data type is there, accordingly the space will be provided, and that will be recorded in the memory, and that would be being automatically, but if you are going to study, definitely you will get that these are the particular details for that. So this is the implementation level, how the particular values are stored into the symbol table, data structures, how work, how the information is flows into that. These are the basic implementation activities. Now data structures we have to start. So the different data structures of symbol table are, the first one is list. So required to make n entries and m inquiries. So that is the basic phenomena that is not related with list. Whatever entries are there and whatever inquiries we require, we have to fulfill all both requirement over there. So if you are talking about list, so you have to see that the name 1, data 2, and this is the basically available place. Okay, so you will see that it is a kind of basically queue, and you have to enter the data at the last. So the data will be stored after that last vacant. You have to store whenever you accessing whatever data is entered last, that would be accessed last. So that is the order. Why it is used? It is very basic data structure, and you are aware about that, and you have earlier study in data structure also, and in algorithm design you also using this queue, and everywhere when algorithms are used and other things are used, you will use this queue. So what is the characteristic of this data structure? It is easy to implement. Why? Because very simple structure is there, but when the data set is large, then it will create a problem. Addition is very easy because you have to add the data at the last of this. Retrieval of information is also easy. What is advantage? Minimum space is required, addition in table is easy. But what is disadvantage? The higher access time. So according to this advantage and disadvantage, we have to decide that for which kind of data we have to use this list. So that is the helping into the deciding of a decision of your database, decision according for accessing of your database. You can take the decision according to that. Where space is very important, addition is important, definitely you have to use a where at that place list is okay. But if you access the data and you would require the minimum access time, that particular list data structure is not up to the mark. So we have to switch over for some another data structure. The second data structure is binary search tree, BST. You know about the BST? That is this. Okay, that value is lesser value, that is higher than that, and that is stored here. So this is so efficient approach to organize symbol table with two fields left and right. So that is loop left and right. Okay. If you are going to search any name in BST, how you can search? Suppose there is a tree given. Okay, here 5, 3, 4, 2, 6, 7. Suppose we want to search 3. Then what we have to do? We have to traverse the route. At the route, whatever value we are giving, we have to check the value that is accessed by this binary search tree. So what we have to do? We have to check. If it is less, then left subtree is preferred. If it is greater than, then right subtree is just move to the right subtree. So it is efficient approach to finding out the values. Algorithm for searching name in BST, P equals to initially a pointer to root, definitely 5. If name equals to name P, if root is already matched with that, definitely it is. Else, if it is less than value, so you have to switch on to the left part. Otherwise, you have to switch on to the right part. So addition is very easy in that. Okay, how addition is easy? You have to traverse whole and finding out the particular empty node, and you have to insert that. Okay, when you traverse, definitely it generate the traversing time is log n base 2. The addition time is also log n base 2, and the deletion time is also log n base 2. So the complexity of this particular binary search tree is very good, and it is much better than this particular list. Okay, if if any particular node is not available in that, so we have to just generate that the search is nil because that element is not found out. Next one is hash table. It is very strongest data structure for storing the data, because there is a table and there is a hash index is used, and this has index directly connected with the particular values, and you can use by this fast accessing find out in the data. So it would consist k words 0 to k minus 1, then pointers into the storage table, that is linked list are used in that. So linked list is having data and link. So this link is associated into that. Searching name is this hash table is apply hash function to name. H name is equals to 0 to k minus 1 integer. So whatever particular integer is matched with the particular name, through that you can access directly. So whatever data set, either it is very larger, after that, in spite of the data set is very larger, what we are doing, we are still concise it into 0 to k minus 1 and we can fastly access any data, but the structure is very complex for that. So when you are designing it, the maintenance of this data structure is very tough. So here is given addition new name, create a record at available space in a storage table and link that record to H. So you have to add into hash list, but hashing is more better accessing time than BST, and BST is more better accessing time than linear list. But the only problem is that it is very complex. If you are moving from this side to this side, this one is going to be much complex, and hashing is very complex. So maintenance of hashing is very tough. So if required, you will generate, otherwise you will use these kind of data structure. Then representing scope information is symbol table. How the variables scope is representing. There is a program where a binding is active. The same name in a different scope can have a different binding. Definitely. Suppose we are procedure X here, procedure Y here, also X is there. In both the particular procedures, the X and X, the value of X and X is different because the overall, because it is the local part of this procedure. So that is the important thing. So it depends upon the scope where the binding of this variable with which particular program. Rules for governing scope, if name declared within a block B, then valid only within a block B. Like if you are talking about B2, whatever variables are defined into B2, that is only declared into that, and that scope of this variable into that. If you are defining any variable in that place, definitely the scope of this variable is here. So scope is basically binding with the procedure or binding with the particular program. So maybe you can define that a global variable scope is everywhere in the program. Local variables is associated with the particular procedure. Require complicated symbol table organization. Like if you are seeing is this program, there is a main program variable XY is defined. Then in main program procedure P is that variable X is defined, that is boolean. Procedure Q is there. Then procedure Q, there is begin and end. There is different program fragment is there, different statements is there, and these are activated. So you will see that in procedure P and Q, these are on same level. So whatever variable X is defined in procedure P is different from procedure Q, because the X is binding with the procedure Q and here X is binding with the procedure P. This variable is basically global variable because it works during the whole particular program, because it is a part of main. So that is the basic scope of this variable. So use of multiple symbol table, one for each block. You can generate different tables, because whenever you are talking about active procedures, definitely their activation record we are just calling up, and when activation record is put up, then the procedure activation is there at the time which procedure is activated, either is an inner procedure or external procedure. At that time only the parameters of those procedures will be affected, other parameters will be stable at that time, and whatever value supplied by that procedure, inner procedures variables are affected during that. So this is the process of this scope information. Then symbol table organization that compiles with the static scope information rules. So next technique to represent scope information is write nesting depth of each procedure block. So if you are talking about this previous, what we have to do, we have to just write some procedure block, and for every procedure block we have to just noted down the stack allocation scheme, static allocation scheme, or heap allocation scheme, how the data is stored, what is the flow of data. Then use pair procedure name nesting depth to access the information from the table. So for each procedure, we have to create a data set. We have to create a particular symbol table, and in that symbol table, the local variables are used, and that is associated with the main. So we have to generate a complete state allocation diagram for static and dynamic part, where the data sets are stored onto the front of starting part of that, then accessing part is below down. So whatever lower level memory that stores the data, after that higher level memory is just part having the execution part. So this is from my side. Thank you very much.